Okay, we're doing question 8, 2022. Let's take a look at the grading. We're going to get 10, 10, and 5. So this will be worth 10, 10, and 5. Okay. 10 minutes, 25 marks. Let's reduce that to 2 minutes, divide by 5, divide by 5. 2 minutes, 5 marks. 1 minute, 2.5 marks. Every minute we're picking up 2.5 marks or more, hopefully. Let's see how we go. So the diagram below shows two vertical buildings, building A and building B. Very tall buildings if this is their width, anyway. They're not to scale. Mary stands at the top of building A. Mary's here. She is 220 meters above the ground. And we're ignoring her height, obviously, or she's lying down or something. That's just our model. She wants to work out the distance marked y. How long is this length? Y. And what else does Mary want to figure out? And z in the diagram. So that's what she wants to figure out, these two values. Great. So we're understanding what's required. We don't know how to do it yet, but we understand what's required. That is the distance from the top of building A to the bottom of building B, yes, and the height of building B, respectively. Okay, fine. Mary measures the two angles that are marked 35 degrees and 20 degrees, with probably a clinometer, right? Is that what it's called? And the broken line is horizontal. Okay, that's important. And we're assuming, not only assuming, we're assuming this building is vertical, that's horizontal, so this building is vertical. And that's great. Vertical buildings are good. We don't have the Leaning Tower of Pisa here. Super. Okay, let's see what we have to do. Work out the size of angle C. So we haven't been asked for X and Y yet, have we? Presumably we're going to be getting them, X and Z, but work out the angle C. So let's take a look. Here's angle C. We know the angle opposite it. Sorry. Oh yeah, well this is really easy because this is called the complementary angles. So two angles are complementary if they add to 90. Okay? And so you could say, okay, this is 90 degrees here, and just say all the angles in a triangle add up to 180. So you can go 90 plus 35 plus C equals 180. But equally so, in a right angle triangle, we prefer to just say the two acute angles sum to 90. Okay, so C plus 35 equals 90. We'll transpose that term across, take 35 from both sides. C is equal to 90, take 35. C is equal to 55 degrees. Okay. So far, so good. Okay, you could have also used tan, but by far the easiest way was this way. Mary works out that the horizontal distance between the two buildings is 154. We're given that anyway. Correct to the nearest meter. Use the theorem of Pythagoras to work out the distance marked y. Okay, so we have Pythagoras here on the bottom of page 16, and we have effectively we have A and B. We have 220 and we have 154. So using Pythagoras in its current form given on the page, we have that y squared equals 220 squared plus 154 squared. Now you can calculate that and then take the square root, or we can go and take the square root immediately. So we'll be spending less time on our calculator and more time doing maths. Plus 154 squared. Okay. So am I in picture? No. We'll go the square root of 220 squared use the square function because it brings you back down off the power, and 154, and we'll just go with equals. We'll take that third value, they'll often want it, and because they're looking for the nearest meter, we'll look at it digitally. You can use the ST button, or you can use shift equal, it's the same thing. 268, and I tell you that because on the newer calculator shift equals is really the only practical option apart from digging into menus. 268.544, and we're going up, so equals 269 meters. Your answer correct to the nearest meter. Okay. Quick thing to check is it larger than the larger of these two? It is, and that's important because there's something wrong if it isn't. Okay, now we're going to use trigonometry to work out the value of Z. Okay. So we can include this value now, 269, on our diagram, and we can, because the buildings are parallel and everything, we can bring this 154 up to here as well. Okay. And because this is a vertical building and this is a horizontal line, we can fill in the value for C, which is 55 degrees. It's also the value here, because not only do those two add to 90, these two clearly add to 90 because they are 90. So that's 55 degrees, and there's other ways of explaining that too, like their alternate angles. Okay, so this is our current situation. Now what I've just been doing there is generally referred to as angle chasing, and it's chasing from one piece of information to another. It's filling in bits of information that you can easily get through simple theorems on your course before you actually knuckle down to the real job of trigonometry. Okay, so I've done all my angle chasing now, and now I need to come up with a plan. Now the way I see it is Z can be partitioned into two parts, into this and this. I can just put letters on them, call them A and B. Okay, and it's just something I want you to be able to do. You should be able to introduce letters for stuff you want to get. It then means you can mathematize it. Okay. So looking at this now with 20 degrees, we're going to need to use the sine, cosine, or tan ratios. Okay, and we need to know which one we're using. So basically when you look at 154 and A, the included angle between them is a right angle. And the one here with the included, and when we use A and B, the included angle here is a right angle. So which one has A and B? Tan of A. So you're going to go here and say, well, I know now that a tan of A is equal to what I want over what I know. But we can do better than that. We can say it's the tan of 20 degrees. So what we have here is we have an equation with one unknown. I should have gone straight to that, by the way. I maybe should have written up the tan of A is equal to A over B, but this is quite meaningless unless you include the actual diagram where it comes from. So A, B and C, and angle A is always opposite A and so on, angle B is opposite side B, etc. Okay, so here we are. Now how do we isolate A? What piece of algebra will isolate A? Well, we want to undo the divide by factor 154, so we want to bring it up. Okay, so A is equal to 154, it's coming up here if you like, times the tan of 20 degrees. Okay, and that goes in your calculator. And you don't need any multiplication symbol or anything here, you just go straight into tan of 20 degrees. Close your bracket, be daring and don't close it. If there's nothing very compound in here, like a calculation to do, you'll get away with it. Okay, 56.051 ... If you're truncating, don't worry about where you're truncating. If, oh, it's a 9, I better put it down. Like, it doesn't matter because we're going to be cutting it well short of this when they ask us to round. I want to say something else about this. This is truly irrational. it's not, there's no surd in there, nothing. It's the messiest type of number. This is as irrational as pi. Okay, 56.051. We'll leave it at that for a minute, and we'll go off and get b, and then we'll see about, we might add them together as real numbers, and then we'll round, because you have to be very careful with rounding sometimes. So let's say you round two numbers down from around 0.4. We'll add it together, they would have been 0.8, and you should have rounded up a bit. So you round later on in a question. B equals, or to get b, what are we going to do? Well, we know 269 and we know 154. Okay, so we have a choice. We can use Pythagoras, or we can use sine, cos, or tan. So we're going to do both. But I wouldn't suggest you need to do both, but it is good to do both, because that way you'll be able to check your answer. So in one case we can go with the Pythagoras when you're getting a leg which has a difference in it. So it's 269 squared minus 154 squared. Pop that in your calculator. While it looks messy, the calculator will do all the hard work, so it doesn't matter that they're big numbers. 269 squared minus 154 squared. Okay, 220.556. And the other way will be to use the fact that we have 55 degrees here. We want b, and we know this is 54, so we could use tan again. Okay, and you could say, well, I know that the tan of 55 degrees is equal to b over 154, and bring up the 154 in front of tan 55, and we'll get the same answer. Watch out, it's like magic. Maths is like magic, isn't it? So here we go, 154 times the tan of 55 degrees, 219.93. Why are they slightly different? The only reason is this was rounded. Well, if that was rounded and that one isn't, which one do you think we should use? We should use this one, because there's no rounding has happened yet on this one. So, and that makes the point what I said about rounding. Rounding gets concatenated, it builds up. So this is a better answer, 219.934. We'll add that to this, and then we'll round again, because we're not really rounding now at this stage. So I'll take all of that and I'll add on this bit, plus 56.051 is 275.98. We can see clearly this is clearly becoming 276 without any question at all on it. 276 meters. Okay. I think that'll be it. Yes. So let's see how we did. And all of that for 5 marks for those who are kind of losing heart and thinking their exam, because they can't do one part of a question. You know, remember, what we're seeing is the hardest parts of the questions are worth the least. Okay, so we got our 55 degrees and we got 269 to the nearest meter. 2 is y. Yeah, we got that. Degrees and 269, and then on the next page we'll get the rest of the marking scheme here, and we get 276 when you add them together. Okay, and they did go with the tan and the adding the values together and so on, and they got 276 meters. Okay, with full marks on that. After all that, we got 5 out of 5 for that bit. And as always, students, I'll see you in the next one.